Have you ever encountered this situation when using an oscilloscope? As soon as the probe was connected, before the signal was measured, a waveform resembling a sine wave but filled with noise appeared on the screen. Don't panic. Today we're going to reveal its true nature, 50 Hz power frequency interference. Let's look at a few interesting phenomena first. Open the oscilloscope measurement function to see that the waveform frequency is stable at 50 Hz. As the probe slowly approaches the oscilloscope, the noise decreases and the waveform becomes clearer. When you touch the signal end of the probe with your hand, the amplitude will increase significantly. After adjusting the vertical position, it is still a 50 Hz sine wave. All of this stems from the power system. The grid is 220 volts, 50 Hz. Wires, sockets, and various electrical appliances indoors all emit a 50 Hz electric field. There are two main ways in which oscilloscopes can be interfered with. First, it is transmitted through power cables. Second, as is the case now, the probe is exposed to the air like an antenna, receiving interference signals from space radiation. What's more interesting is that the human body is also a large conductor, equivalent to a giant antenna, which can receive more electromagnetic radiation. Therefore, as soon as your hand touches the probe, the interference signal becomes stronger. Now that we have identified the cause, we can find a solution. First, ensure that the oscilloscope is properly grounded. Grounding not only prevents electric shock, but also allows the oscilloscope and the measured signal to share a common ground, thereby shielding noise. As can be seen, the amplitude is very large when the hand touches the signal end of the probe. When the other hand touches the ground wire of the probe, the amplitude immediately decreases. Secondly, reduce the antenna effect of the probe. The probe and ground wire of the probe form a loop, which acts as a small antenna. We replaced the long ground wire with a standard grounding spring, shortening the length and significantly reducing interference. If that doesn't work, try reducing the electromagnetic radiation around you. Turn off the electrical appliances nearby, or test in a room with fewer electrical appliances. With fewer sources of interference, the signal is naturally purer. The last resort is to use a filter. A filter specifically designed for 50 Hz can directly filter out power frequency interference. Let's get a truly clean test signal. Summary: 50 Hz power frequency interference is a minor issue in power systems. It can be effectively resolved through proper grounding, optimized probes, reduction of radiation sources, and the use of filters. Master these techniques, and your oscilloscope measurements will be more accurate. Follow us to get more testing tips.